To the lesson number 5 of IGCSE Mathematics course, Ratio and Proportion. Here we're going to cover two syllabus objectives, E1.11, demonstrate an understanding of ratio and proportion, increase and decrease a quantity by given ratio, calculate average speed. This one actually we're going to go through in the next lesson, and we have to use the measures of rate. And another one, calculate using money and convert from one currency to another. So we will also talk about money quite quickly. Okay, so let's start with ratio. Let's see what we can do here. So I prepared two questions on the ratio. The first one is a man and a woman share a price of $1,000 between them in the ratio 1:4. The woman shares her part between herself, her mother, and her daughter in the ratio 2:1. How much does her daughter receive? Okay, so this is a two-step question. Actually, the first step, we have to figure out how much money exactly the woman got. So when we know how much money she got, we can figure out how much she gave to her daughter. So let's start with it. So the first step. First of all, so there's $1,000 in total, and they're split. If we see this, they're split in ratio 1:4. It means that in total, they're split in 5 parts. There's 5 parts in total. We could see that. And so the question about ratio and also about proportion is almost always the question is how much is one part. Alright, so the question is always how much is one part. In this case, so $1,000 is equal to 5 parts. Then we can say that one part, if we divide both sides by 5, we will get that one part is equal to $200. Alright. Okay, man and the woman, so be very careful about the order of the words in this question. Man and woman, 1:4. So it means that man gets one part, man gets one part, and woman gets 4 parts. It means that in total, woman gets 4 times 200. She gets $800. So that's how much the woman gets. Okay, she shares her part between herself, her mother, and her daughter in the ratio 2:1. Again, be very careful. Herself, mother, daughter. 2:1. Okay, so now we have $800. So that's the first part. Oops. Yeah, I was trying to make a nice line. Yeah, something like this. And now the second part of this question, so $800 are shared. Oops. $800 are shared in the ratio 2:1. It means that in total we have 4 parts. Oh, that's actually quite easy. So 4 parts. It means she didn't change anything about the parts. It means that one part is still the same. Sometimes this is not the case, but this question is actually quite easy. So one part is still equal to $200. But sometimes you have to do the calculation again. So $800 equals to 4 parts. It means that one part is equal to $200. And this is actually how much the daughter gets as well. This daughter receives, because daughter receives one part. Daughter receives one part, which is equal to $200. Okay, it's actually easier than I thought. But anyway, it's quite a comprehensive question. I hope it makes sense to you. Okay, next question is quite different actually. If y/18 equals 8/y, calculate the positive value of y. So in this question, we can use a special property of proportion, the special property of ratio, which is the ratio can be expressed as a fraction. So y to 18 can be written as y over 18. 8 to y can be written as 8 over y. Please remember, the first part goes on top, second part goes on to the bottom. And now we can just solve this equation. That's it. You can just solve it. So y over 18 equals 8 over y. What we can do is we can cross multiply this. So we will get y times y equals to 8 times 18. So y squared is equal to, what's it going to be? It's going to be 144. It means that y is equal to square root from 144, which is equal to 12, right? So that's an important thing. Ratio can be written as a fraction. Just pay attention to what's on top and what's on the bottom. Okay, that's it for ratio. Next, we have proportion. Couple of questions. Okay, first of all, a car uses 10 liters of petrol in 75 kilometers. How far will it go on 8 liters? Okay, here also we can actually use the fraction. It's fine. So 10 liters can be used for 10 liters for 75 kilometers. And how far will it go on 8 liters? Right, so 8 liters, we don't know kilometers. We can do that. There are actually some exceptions. This method cannot be used in every case. I will show, actually the next question, you will see why in the next one. Okay, but for now, let's just try to use this method. So here you can see we have this question mark. We can replace it, of course, with x. Important part of this, again, liters have to be on top, kilometers on the bottom. So they cannot be, it cannot be like this, kilometer here and kilometer here. This is not acceptable, so just keep that in mind. All right, so let's do this. I'm going to replace question mark with x, so we will get 10 over 75 equals to 8 over x. Again, we can cross multiply. 10x equals to 8 times 75. 10x is equal to 8 times 25 is 60, 600. It's going to be 600. 10x equals to 600. It means that x is equal to 600 over 10 equals to 60. So that's our answer. So car will go 60 kilometers on 8 liters. This is actually first method we can use. There's one more method here. Method number 2. So what we can do is, we know that 10 liters will give us 75 kilometers. All right, so we can ask the question, okay, so 1 liter would be how many kilometers? We could do it this way. So the answer would be, we would have to divide it by 10, all right, and we would get 7.5 kilometers. So 7.5 kilometers for 1 liter, and then easily we can figure out that from 8 liters, it would be 8 times 7.5, which would be 60 kilometers. So that's the second way. Actually, why do I show you the second method? Because this is the only method you can use in the second question here. So that's the number 1. That's question number 2. Question number 2. So this is what's called reverse proportion. Let's read it carefully. A wall can be built by 6 men working 8 hours per day in 5 days. How many days will it take 4 men to build the wall if they work only 5 hours per day? So first of all, let's simplify this question. 8 hours per day in 5 days, that's too complicated. Let's just say that 6 men can build the wall. What's happening to my pen? Not working that well today. Okay, one more time. So 6 men can build the wall so 8 hours per day in 5 days. That's 8 times 5. That's gonna give us 40 hours. 6 men can build the wall in 40 hours. All right, we could say that. 4 men. Let's just, first of all, let's find how many hours it's going to take them. Let's find that out. 4 men, how many hours it's going to take them to build the wall, right? So the methods which we used before, actually it's not going to work that well before anymore. Just try to apply the logic, right? If we try to, for example, let's say that we find out. So what if we do it like the last question? We would do this, right? We would find out that for one man it would take, so we would do 40 divided by 6, so it would be 40 over 6, which is like 6 2/3 of hours. So does this make any sense? It doesn't make any sense, right? So how does this happen? 6 men, they spend 40 hours, but for 1 man, if we do it the way we did the last question, if we just divide this by 6, for 1 man it's going to take 6 hours? What? No, so this is not the way to do this. This is not the right way to do this. Just try to use your logic. This is impossible. How comes that 1 person can do it faster than 6 men? So actually, again, this is an inverse proportion question, a little bit tricky one. Normally, inverse proportion questions, almost all of them are about labor. So you will be able to detect them quite easily. So actually, what we have to do is we have to multiply it. So 6 men, if 6 men do it in 40 hours, then it means that for 1 man, it will take 6 times as much time. All right, so it will be actually 240 hours. For 1 man, it's going to take 6 times as much time. It's going to take him 240 hours times 6. Right? And now we can figure out how long it's going to take for 4 men. Right? If for 1 man it took 240 hours, then to figure out how long it's going to take for 4 men, we can just take this value, 240, and we can divide it by 4, because we know that 4 men will work 4 times faster than 1 man. Right, so we just divide this by 4. 240 divided by 4 will be equal to 60 hours. Okay, so for 4 men, it would take 60 hours to build this wall. Right. Okay. So the final question actually is how many days will it take 4 men to build the wall if they work 5 hours per day? So it will take them total of 60 hours. It's going to take them total of 60 hours at 5 hours per day. So divided by 5, it's going to be equal to 12 days. So this is going to take them 12 days to do this work if they work 5 hours per day. Okay, I hope it makes sense to you. All right, so that's it for proportion. One more topic, quite a hard one actually, I must say, foreign exchange. A lot of confusion about this topic. So let's just do this question. I think this is kind of an all-encompassing question. A family on holiday in France exchanged $450 for euros. When the exchange rate was 1.41 euros to the dollar, they spent 500 euros and then changed the rest back into dollars, by which time the exchange rate had become 1.46 euros to the dollar. How much did the holiday cost? Answer in dollars. Okay, so here again, just like with proportion, we have to apply logic all the time. So let's just try to figure it out. $450 were changed for euros. We can also use proportion, by the way, for this question, so people find it very useful. So $450 gives us, we don't know how many euros, right? We have no idea. We don't know. But we do know, my gosh, my drawing is so terrible. We do know that exchange rate was 1.41 euros to the dollar. So $1, we know that $1 is equal to 1.41 euros. Right? So how do we figure out this part? Well, again, there's two methods here. First methods we could just figure out, okay, so 1 to 450, how do we get from 1 to 450? We do times 450, and here we would also have to do times 450. So we would get, let's get the calculator for this one, 1.41 times 450 is going to be equal to 634.5. So they will get 634.5 euros. Let's move this a bit. Okay, and the second method you could do is you could do this. You could say 450. You could say 450 over 1 equals to x. So this is 450 over 1, kind of goes here, equals to x. So this is x, this is this unknown, over 1.41. Okay, yeah, this pen, I don't know what's going on with it today. So this could be another method. You could just use the fraction. I think I showed this method in the last question, so I'm not gonna get back to it too much. Okay, this is only the first part of this question. This is how much they got. They got 634 euros. Then look at this, they spent 500 euros, right? So we get this 634.5 minus 500. It means that they have 134.5 euros left. Right, and then they changed it back to dollars. Then they changed it back to dollars. So now, but now there's a new course. We have the new course. The course is 1.46 euros. So 1.46 euros to $1. Right, and we want to change 134.5 euros by this course. Right, how does this happen? Okay, this is actually where we can use the methods that I just showed you. So we can say that we can transform this into the fraction. 1.46 over 134.5 equals to 1 over x. We could do that. So now we can do the cross multiply thing. 1.46 x equals 134.5. It means that x equals to 134.5 divided by 1.46. You can get the calculator for this one. 134.5 divided by 1.46. Oops. I think two decimal places is enough. So $92.12. $92.12. This is how much they got in the end. So right, so they came. Okay, so the final question is how much did the holiday cost? How much the whole holiday cost this family? All right. Okay, so they came. They had $450 in the beginning. In the end of the holiday, they got what was left is $92. So how do you find the total cost? Well, we just subtract it, right? So cost is $450 minus 92.12, right? This is going to be equal to 357.88. So this was total cost of their holiday. Very cheap holiday in France, I must say. Probably some long time ago. Okay, anyway, that's the answer. I hope this makes sense to you. Okay, let's get to the next part. Map scales, finally. So yeah, map scales are also connected to proportions and ratios, which is actually why they are in the same topic. So let's just do this question quickly. A map is drawn to the scale of 1 to 2000. Find the actual distance between 2 points which appear 15 centimeters apart on the map. Okay, so let's do this quickly. So the actual distance between 2 points which appear 15 centimeters apart on the map. So 1 to 2000, it's important to realize that 1 is about the map part, and this is in reality, right? In reality. So whatever is 1 part on the map becomes 2000 parts in reality, right? The actual distance between 2 points which appears 15 centimeters on the map. So 15 centimeters on the map is going to be how many centimeters in reality? Well, what we can do, we can see that from 1 to 15, we can just times this by 15, right? And this also can be times by 15, would be equal to 30,000 centimeters. 30,000 centimeters doesn't really look that well, so we can convert it actually to meters, especially when it comes to the actual distance in the actual real world, right? We normally never say, okay, that thing is 30,000 centimeters from me, so we can convert it to something more believable, which would be meters. We can say that this is equal to 300 meters. We could say that, and this should be your answer. Or actually, if you answer in centimeters, it's not a mistake, but just try to find some appropriate unit for your answer. Okay, next one, the length on the map of a road, which is 1.2 kilometers in length. So let's do this. Again, the scale is 1 to 2000. The road is 1.2 kilometers in the length. What do we get here? What does it become on the map? Here we can use the equation method. So we can say that 1 over x equals to 2000 over 1.2. We could do that. I can cross multiply. 2000x equals to 1.2. X would be equal to 1.2 divided by 2000. This would be like a really small number. 0.00. Wait, actually, let's just do this quickly. 1.2 divided by 2000. 0.006, yeah. So yeah, this doesn't really look pretty, 0.0006. So why don't we convert this? We can convert this. So this would become, if we multiply it by 1000, this would become 0.6 meters, right? And then 0.6 meters can become, if we multiply it by 100, this can become 60 centimeters, which is a pretty good answer. Okay, that's it for B. And finally, C. C is actually quite complicated. I think I need one more page for this. All right, let me copy this part. Okay, so C is quite tricky, I would say. So area on the map of the field, which with an actual area of 60,000 meters squared. The thing about areas is they don't scale in the same way as the lengths do. So let me give you an example. Let's say on the map, let's say we have the map, and let's say we have a real version of this map, so 2-in-1. So map, this is map, and that's gonna be the part which is about reality. So let's say in reality we have some field, which is, let's just use 1 unit. I'm just gonna use 1 unit, not to make this confusing. So let's say some field which is, I don't know, let's say 500 meters by, I don't know, let's say also 500. It looks the same, like a square, right? So you can see that the area of this square would be 500 times 500. The scale, by the way, let's suppose that the scale is 1 to 100 for this one. So the area of this square in reality would be 500 times 500. That would be 25 with 4 zeros, 250,000 meters squared, right? So when we translate this to the map with the scale of 1 to 100, this would become 5 meters by 5 meters. And this would actually give us the area of 25 meters, right? So you see that 25 versus 250,000 does not really correspond to the ratio 1 to 100. This is actually a ratio of 1 to what? 1 to 10,000. That's a ratio of 1 to 10,000, ladies and gentlemen, right? So why does this happen actually? Why is it so confusing for areas? Well, because there is actually an easy formula. So the scale factor of length squared is equal to scale factor of areas. So for example here, if we have 1 to 2000, the scale that we have, the scale is always a length scale factor, right? So for area, the scale factor will become 1 to 2000 squared, right? So this is for length. Scale factor for area will become 1 to 2000 squared, basically. So that's going to become 1 to, what's this going to be? It's going to be 4 million. 1 to 4 million, right? And if we have, we have 60,000 meters squared is an actual area, sorry. The question is, what does it become on the map? Well, let's figure this out quickly. So it's going to become, we can use the equation here. All right, so that's an important part. Let's translate this into a fraction. So 1 over x equals to 4 million over 60,000. So x is going to be equal to what? What's it going to be? X is going to be 60,000. Oops. 60,000 divided by our 4 million. 6 over 400, that becomes 3 over 200, 1.5 over 100, 1.5 over 100. That becomes 0.015 meters squared. So this would be an appropriate answer, but if you want, you can convert this to centimeters. So 1 meter squared equals to 10,000 centimeters squared. You can convert this area to centimeters, by multiplying it by 10,000. This would be equal to 150 centimeters squared. So this would be a good looking answer. Okay, that's it for this part. Quite an interesting topic, I would say. Well, anyways, see you guys next time. Have a good day.